Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 9 from the May-June 2002 Cambridge 9709. This is the paper 1, the Pure Mathematics 1 paper, and this question is a question that I have included in my end-of-topic worksheet, number 11 for differentiation 1. And part 1 of this question is to do with actual differentiation and, well, kind of to do with differentiation. Part 2 of the question is more to do with integration, so I'm going to save that as a separate file. And part 3 is to do with in differentiation, but related rates of change. So I'm going to make 3 separate videos from this one question, so I can save the videos in different playlists according to topic, and I'll also save them in this playlist for this paper and for this end of topic worksheet. So now, a curve is such that dy dx equals 12 over 2x plus 1 all squared, and P 15 is a point on the curve. The normal to the curve at P crosses the x-axis at Q. Find the coordinates of Q. So in this case, the original function y equals some function of x, whatever it was, which we can find in another part of the question, I think part 2. All right. It's been differentiated already. It's already been differentiated. This is the when you differentiate the original function y, it gave us dy dx. Okay, so when you go from y to dy dx, or when you go from f of x to f dash of x, you're going this way, it's like you have differentiated. That's differentiating. Go the opposite way, it's integrating. Right, so now, so we want to find the normal to the curve at P. Okay, no, sorry. It says the normal to the curve at P crosses the x-axis at Q. Find the coordinates of Q. So we got to find the x coordinate of the point Q, okay, which crosses the x-axis, okay, and it is the point where the normal to this curve, okay, the normal to this curve at this point P crosses the x-axis. So we have to find basically the normal to the curve at P. That's what we have to find. And then once we found that, we can find where it crosses the x-axis, and that will tell us the coordinates of the point Q. Okay, so we have to focus on the normal to the curve at P. Now the normal is a straight line. So for example, let's imagine you have a curve that looks something like this. The normal to a curve is a straight line. Okay, it's a straight line, and it's kind of related to the tangent of the curve. Say this is the tangent to the curve at this point. The normal to the curve is a line which cuts the tangent at 90 degrees at that same point. So it's perpendicular to the tangent. So this would be the tangent and this would be the normal, and they are perpendicular to each other. So the tangent shares the same gradient of the curve at that point, but the normal has a gradient which is perpendicular to the tangent. Okay, so we can say that the gradient of the tangent, okay, at P is when x equals 1. And so we can say dy dx is going to be 12 over 2 times 1, okay, plus 1. And all of that is squared. Okay, so 2 times 1 plus 1, and that is squared, right? So 2 times 1 plus 1 then squared. That gives you 12 over, that's 3 plus 1, which is 4. Sorry, 2 plus 1, which is 3. 3 squared is 9. That gives you 9. 12 over 9, which is the same as 4 over 3. Okay, so the gradient of the tangent at P is equal to 4 over 3. Therefore, the gradient of the normal at P is going to be the negative reciprocal. So you take the fraction, you change its sign. If it's negative, it becomes positive. If it's positive, it becomes negative. And then you write it as a reciprocal. So the numerator and denominator switch places. So that is the gradient of the normal at the point P. And the point P, as we know, is 15. So now we can find the equation of the normal. Now the normal, okay, is a straight line. And we can use the formula y minus y1 is equal to m times x minus x1. And this is like x1 and this is like y1. We can use this formula. We can even use the other formula, which is y equals mx plus c. Most students after IGCSE insist on using this. I like to use this formula myself. Okay, so y minus the y coordinate of this point, which is 5, equals m, which is minus 3/4 times x minus the x coordinate of this point, which is 1. Okay, so this is the equation of the straight line. Okay, in its like basic form. We could actually find the equation of the straight line, but actually what we need here is just to find the coordinates of q. You don't actually have to find the equation of the normal. We can just find the coordinates of q, and we know on the x-axis, we know that y is equal to 0. So if I replace the y with 0, I'll have 0 minus 5 equals minus 3/4 times x minus 1. Okay, so now we can find the value of x. What happened here? 1 second. So we can say minus 5 is equal to minus 3/4 times x minus 1. So I can multiply both sides by 4. Minus 20 equals, and I can expand this, minus 3x plus 3. So we can say 3x is equal to, that's going to be 23. Okay. Is that right? Yep. So x is equal to 23/3. Okay, so that's the x coordinate of q. So that's the x coordinate of q. And the question says find the coordinates of q. So that means we have to write it in the coordinate form. And we know that this is when y equals 0. So the point that we need is going to be 23/3 and 0. So that's the answer to part 1. Now part 2 is to do with integration. So I'll save that in another playlist to do with integration. And part 3 is also differentiation. It's related to differentiation, but it's to do with rates of related rates of change. So I'll also put that under a different playlist as well. Okay, so basically, I will stop this video at this point. And if you would like to see the rest of this question and other questions from this paper that I might have answered, you will find the playlist at the top of the screen at the end of the video, which you can click to take you there. If you'd like to watch the other parts of this question and the rest of the questions from my end of topic worksheet on differentiation, you'll find those in the playlist that will be, linked at the bottom right of the screen at the end of the video. And if you'd like to see my P1 material on differentiation from Cambridge, you can click on this link. And the link in the top here will subscribe you to my channel if you haven't already done so. Thank you for watching and see you soon.